Hello everyone, I'm Engineer Lou from Docan. In today's video, we're going to talk about a problem that many battery users may experience. Why does my battery SOC suddenly jump? Why does the voltage difference between cells become larger and larger? When many people see this problem, their first thought is my battery cell damaged? But actually, there can be many different reasons behind this issue. It could be caused by cell imbalance, sampling wire problems, the balancing system, or even the BMS
对，
itself.
可以理解你的这个是。
So today, I will show you how to troubleshoot this problem step by step. The goal is to help you find out which part of the battery system
那
is
也
actually
可以，
causing the
我是
problem.
1.2。
First, please remember one important thing. Although the battery pack I'm showing today may look different from yours, the troubleshooting logic is almost the same for most lithium battery systems. Different brands may use different BMS models, wiring structures, and layouts, but the basic principles remain the same. Before we start checking the battery, we need to confirm one condition. It is recommended to perform the inspection when the battery pack has a clear abnormal voltage imbalance. By abnormal imbalance, I mean when the highest cell voltage reaches around 3.45 volts, but the battery pack still has a significant voltage difference between cells. Or during discharge when the lowest cell voltage is close to around 2.7 volts, but the voltage difference is still unusually large. So why do we recommend checking around 3.45 volts? Because for LiFePO4 cells, when the cell voltage reaches around 3.45 volts, it is usually already entering the end stage of charging. At this point, the remaining energy that can be stored is already very limited. And continuing to charge will only add a very small amount of extra capacity. And keeping the cell at a high voltage for a long time may also affect the long-term lifespan of the battery. Many users like to charge their cells to 3.6 volts or even 3.65 volts. But please remember, these voltage values are usually obtained under specific testing conditions. They do not mean that every battery system must always reach this voltage during daily use. In real applications, temperature, charging current, cell consistency, and BMS settings can all affect battery performance. Of course, if your system is designed to charge up to 3.65 volts, you can also perform the inspection at that voltage. The same principle applies to discharge testing. You can observe the battery near the discharge cutoff point and check whether the lowest cell voltage is unusually low or whether there is a large voltage difference between cells. All right, now let's start troubleshooting the problem. Step 1. Check whether the battery cells themselves have a problem. First, we need to confirm, is the cell itself actually inconsistent or is the BMS showing incorrect data? This is the question that many users care about the most. First, disconnect charging and discharging equipment and allow the battery to reach a stable condition. Then use a multimeter to directly measure the actual voltage of each battery cell. For example, measure the voltage between the positive and negative terminals of the first cell and compare the multimeter reading with the voltage displayed by the BMS. If the voltage measured by the multimeter is significantly different from the BMS reading, then the problem may not be the cell itself. Please move to step 2. However, if the multimeter reading is almost the same as the BMS display, this means the cells themselves may actually have an imbalance problem, and further balancing may be required. There are several ways to balance battery cells. For example, you can perform a low current charge and discharge cycle on the whole battery pack, then let the battery rest and allow the cells to gradually become balanced. You can also use professional equipment to adjust individual abnormal cells. But please remember, disassembling individual cells requires battery repair experience. It is not recommended for inexperienced users. Step 2. Check whether the sampling wires have a problem. If the cells themselves are confirmed to be normal, the next thing we need to check is the BMS sampling wires. The sampling wires transfer the voltage information of each cell to the BMS. If the sampling wires have loose connections, damage, or poor contact, the BMS may receive incorrect voltage information. Different battery packs may use different sampling wire structures, but the checking principle is the same. First, identify which sampling wire corresponds to which battery cell. Usually, the BMS or the user manual will provide the wire sequence information. For example, on a 16 series battery pack, the first sampling wire connects to the battery negative terminal, also called B. The second sampling wire connects to the positive terminal of the first cell. Nod. So, measuring between the first and second sampling wires gives you the voltage of the first cell. Then, measuring between the second and third sampling wires gives you the voltage of the second cell. Continue this process until you measure every cell voltage. After that, compare the sampling wire measurements with the direct measurements from the battery cell terminals. Nod. If both results are almost the same, the sampling wires are working correctly. Please continue to step 3. If the sampling wire measurement is abnormal, check whether the sampling wires are loose, whether the screws are properly tightened, and whether the connection plates are damaged. If the connections are confirmed to be good, you can try replacing the sampling wire harness. Step 3. Check the communication adapter or connection cable. This problem happens less frequently. Usually, it affects whether the data can be displayed correctly, whether the computer software can connect, and whether communication works normally. If the first 2 steps are normal, but the displayed data is still incorrect, frown. Please check the cable between the BMS and the adapter board. Disconnect and reconnect the cable and make sure it is not installed in the wrong direction. Pause. Because some cables do not have a foolproof design, they can still be connected even when installed incorrectly. Step 4. Check the balancing module. Different battery systems may use different balancing methods. Some balancing functions are built into the BMS, while others use an external balancing module. First, make sure the battery voltage condition meets the requirements for balancing activation. Then check, is the balancing function working? Is there balancing current? And does the cell voltage change normally during balancing? If abnormal voltage difference appears after balancing starts, turn off the balancing function and check whether the voltage difference returns to normal. If it returns to normal, the balancing module may have a problem. Further testing is required, and the related module may need to be replaced. Step 5, check the BMS itself. If the previous 4 steps do not find any problem, then we need to check the BMS. Reconnect all cables properly. Then use a multimeter to measure the voltage of each cell at the BMS sampling connector. If the voltage measurement at the BMS connector is abnormal, reconnect and secure the sampling wires again. If the problem still exists, then the BMS sampling circuit, sampling chip, or related hardware is most likely damaged. In this situation, replacing the BMS is usually recommended. Special situation. There is another special situation that sometimes happens. Some battery packs appear to have a normal voltage difference when balancing is turned off, but once balancing starts, the voltage difference suddenly becomes much larger. If the balancing module is normal and the BMS is also normal, then the problem may come from the cell connection points or the sampling connections. For example, high contact resistance in sampling wires, loose connection plates, or screws that are not tightened properly. Because when balancing is working, current flows through these connections. If there is high resistance at a connection point, it can create additional voltage differences. As a result, the BMS may detect a very large voltage imbalance. In this situation, you need to open the battery pack and carefully check all connection points. All right, that is everything I wanted to share today. When your battery has SOC jumping, large cell voltage differences, or abnormal balancing problems, you can follow these steps to troubleshoot the issue step by step. I hope your battery system can continue running safely and reliably for a long time. I'm Engineer Lou from Docan. See you in the next video. Bye-bye.